Howdy team, welcome to the third installment of our video lecture on arrays. So let's get right to it. Arrays, we've talked about, can be really helpful as a contiguous set of variables of a specified length. And sometimes you know exactly what variables or the value of the variables that you want to insert into the array. And when that is the case, you can use what's called quick array initialization. So in this case, you provide the type, like in this case, we have a type of int and we're calling that variable numbers. And inside we give it the numbers 12, 49, -2. These are the values that we want to be stored. Note that we are not we're not using the new keyword here. We're not specifying the exact length. This is some syntactic sugar on top of array initialization. So it's just going to create an array, in this case of length 7, and it's going to autofill each value in the array to have the corresponding value that was provided in the quick initialization. This is useful when you know exactly what the array's elements are going to be. So it saves you a lot of time instead of having to do this in 8 different lines, one for initializing the array and then one for each of the elements. You can just create them all at once, which is really helpful. The compiler is able to understand the length just by counting the values. It's able to understand that this is a number, or that this is an int array because it's specified here. It's smart enough to take that you provided and copy it over. One thing that's interesting here is that I usually think that these should be square brackets. They need to be curly brackets. I get that wrong frequently. Seems like they should be square brackets. They're not. Curly brackets are necessary in quick array initialization. Okay, you ready for a challenge? Okay, take a second, look through each element in an array. That's called a traversal. You're going to traverse the array and figure out what values are going to be stored in the array. Pause the video now, figure it out. Are you back? Did you really figure it out? Are you just waiting for me to give you the answer? I hope you really figured it out. Okay, so let's see this in the code. I just copied the exact same array here. The only thing I added was that I wanted to print it out at the end so that you could see the output. Let's run it really quick. And you can see this is what the final output of that program is going to be. Let's walk through it. Pretty straightforward. We will walk through it together in a general way. This is not a straightforward problem. And then I have another version of it that's going to tell us at each level what it is that's happening. Okay, so we have this array that we've created here. We are going to traverse the array starting from 0 to, notice here, we are only going to where I is less than a.length -1. So we are not going to touch this last index because we have -1 here when I is less than a.length -1. The length is 7. A.length -1 is 6. So when I is less than 6, I can't be 6. So I is never going to be this last index where there's a value of 11. So then inside, we are making some comparison with the value of I of the value of the array at index I. And then we are seeing if that value is greater than its value to the right. So we'll be comparing if 1 is greater than 7, and then later if 7 is greater than 5, etc. And if it is greater, so if the value at I is greater than its neighbor, we are going to double the value of the neighbor. And then we'll just continue doing that all the way down the line. So I mentioned before that I took this short but not straightforward program and I added some logging, some comments to it that'll print out to the console for us so we can see exactly what's going on. There's a lot of comments, but I promise the code itself is the same. So we've initialized the array here. That's the same. Our loop is the same. The actual calculations are the same. I'm just printing out a couple more things so that we can see what's going on. Okay. When I run this, I'm using a scanner to stop at each iteration so that we can see what's happening. So here we're at index 0. So I is 0 and the value here, the value of the array at that index is 1. So it's 1 because we've set it to 1 up here. So that value is 1, and we need to compare if a at 0, which value is 1, is greater than the value at a at 1, which is 7. So if this value is greater than its neighbor, which its value is 7, then we want to do something. If it's not greater, then we'll do nothing. And in this case, 1 is not greater than 7, so it's going to do nothing. I've again used the scanner to pause input. So I'm going to click the enter key now. Okay, so now we're at index 1. We are here looking at 7. And the value of a at 1 is 7. We're going to compare if 7 is greater than the value at a2, which is 5. And 7 is greater than 5. So we have to do something. And what we're going to do there is here, so here we're saying a1 was greater than its neighbor. 7 is greater than 5. So we're going to double the neighbor's value. So now index 2, instead of it started out as 5, now it's going to have the value of 10. Let's move on to index 2. So we're at index 2. It shows 5 up here, but we've rewritten it to 10. So now we want to see if a2, which equals 10, is greater than the value of a at 3, which is 6. And again, our value to the left is greater than the value to the right. So we're comparing 10 with 6. 10 was greater than 6, so we're going to double the neighbor's value. So 6 is going to double to 12. A at 3 is now going to equal 12. So when we get to a at 3 now, we are going to compare a at 3, which is 12, to a at 4, which is 4. And 12 is greater than 4 again. So we are going to double the left neighbor's value, or the right. I get my left and right wrong all the time. I'm sorry if I've gotten it wrong a couple of times in this video. I'll try to stop using them now. So a3, which was 12, is greater than a4, which is 4. So we're going to double the value of a4. And it's now going to have the value of 8. So now when we are at index 4, we're going to compare the value of a4 equals 8 is greater than the value of a5 equals 14. It is not greater, so we don't have to do anything. Okay, now we're at index 5, and the value of a5 is 14 because we didn't modify this one. And we're going to look at its neighbor. We're going to look at 11. And if it isn't greater, it will do nothing. 14 is greater than 11. So we need to double the neighbor's value. So we're going to double 11 into 22. And so now a6 is going to have the value of a22. And then at the end, just like in the previous one, I'm printing out that array. Printing it out, it looks like this, which is the same input. As you can see here, it's the same loop. I just added some more comments to explain what was happening. So that was a really fun problem. Let's get back to the slides. Okay, so arrays are super helpful, really convenient, do a lot of things, but they have limitations too. There are things that are pretty inconvenient about arrays. Let's talk about those. So once you create an array and you give it a size, you cannot resize an existing array. The array itself, and keeping in mind that an array is only a contiguous block of memory, it is immutable. So that memory address that references or that directs you to that contiguous block of memory, that block of memory cannot be changed. It has only promised that in this case that it has enough room for 4 integers. It cannot promise that if you want to add a 5th or 6th, or in this case, a 10th integer, that it's going to have space for it. It can't guarantee that. And so you cannot resize an existing array. The array is the size that it was created as, and it can get no bigger, it can get no smaller. You cannot compare arrays with equals equals. If you remember, what's stored at the variable is going to be the memory address to the first element in the contiguous array. So in this case, if you try to compare A1 and A2, you are comparing what's in the bits, because that's what the equals equals sign does. It compares what's in the bits at those variables. And in the bits at these variables, it's the memory address. So the memory address of A1 is not going to be the same as the memory address of A2. So we sometimes the compilers do some crazy things. So if you try to run this, it may show you that they are equal. I assure you that that is not consistent behavior. That's not something that you can count on. And so please, please, please don't use equals equals when you are comparing arrays. What you want to do is use the equals method that you've seen in with other reference types. And finally, an array does not know how to print itself. It's pretty inconvenient. It is just going to print out a hex version of the memory address that it has stored in those bits. That's really, really unhelpful. Let me show you in our code what this would look like. I'll do it in this one so it's faster. If I just say I want to print out A, it's going to print out here. It's just the memory address of where in my computer's memory and its RAM, where that's stored. And this is going to change each time I run the program. It's not always going to be the same. Okay, in this case, it is always the same. I don't know why that's the case. It is not something that you can count on. Maybe the Java garbage collector is just really, really fast, and it's able to reuse that same little bit of memory each time. Okay, back to the slides and the inconveniences of arrays. Okay, so arrays can't print themselves. They give you memory addresses, which are kind of interesting because you can see for sure that like this is the value that's in the bits, but it's not helpful to users at all. So because of these limitations, there are some built-in functions that can be helpful for you when you're dealing with arrays. You cannot call these directly on an array. So an array has the equals function and it has a length field, but it doesn't have anything else really that you can reference on it. Nothing else particularly helpful anyway. So the creators of Java created a new class with helpful things in it. It's called the arrays class. You can think of this sort of similar to the math class, for example, where it has functions that perform some operations, some helpful operations that you might use frequently, but it is not, you don't have a variable of type math. Like you don't have a variable of type arrays. You can just use it as a static class. So it is in the java.util package. So you would import it with import java.util.arrays, and it has some helpful methods. So let's go through a couple of those. The syntax of how you would call one of these methods is arrays.method name, and then you send in whatever parameters are necessary. So in this case, you would send in arrays.copyOf, and you send in an array, and then the length of the elements that you want to copy into that array. So we could say, we could make a copy of an array called A, and we can specify the length of A.length. But maybe we didn't want to copy all of them. Maybe we only wanted the first 10. So we could say copy of, and our array is called A, and we can say 10 here, and it will just copy over the first 10 elements. If we want a bigger array that contains the elements that are already in A, let's say A has 14 elements, we can say copy of here, we send in A, and we give it a larger value, is going to give us a larger array that has a bunch of zeros at the end of it. So that would give you a bigger array. You can say arrays.equals. We already talked about that, where you send in two arrays. It is going to make sure that it contains the same elements in the same order. You can also fill. This is convenient if you have elements that, you know how I talked about how the zero initialization, where when you create an array of ints, for example, it sets all of the variables to have 0 value. If you want them all to have a -1 value, or you want them all to equal pi, or you want them all to equal something else, you can use the fill function, and it is going to fill every element of the array with some default value. This is also really convenient when you're trying to, like, you have an array full of values and you want to clear out those values. This is really convenient for that as well. The next one is toString. This is really convenient because it is going to return a string that contains the array. So it's going to look something like this, which is still not especially user-friendly, but it is developer-friendly, and you can understand what's happening in the array. Okay, so let's see what arrays.toString does. First, I just want to say each of these is going to return a new array to you. It is not going to modify the existing array. This one is going to let me start over. I want to make clear what each of these functions does. The copy of is going to return to you a new array. So you'll have to store it in a variable when it returns. The equals function is going to return a Boolean to you. Are they the same or are they not the same? The fill function is actually going to modify the array that you provided, this one here, and it's going to change all of the values on the inside of the array. The toString function is going to return to you a string. It's not going to print it. It is just going to give you a string that you can store in a variable. You can print it. You can do whatever you want with it, but it is going to be a string and not an array. Okay. Let's talk about arrays.toString. Again, it accepts the arrays as a parameter, and it's going to print them out to the screen. Pop quiz, what's the output of this? Okay, we are going to take e at 1, whose value is 2. We're going to replace 2 with e at 3, which should be the 4th value. Here 6, and we're going to add to it e at 4, which is the 5th value. 6 plus 8 is 14. So e at 1 is going to be 14. What it is going to print out to us is 0. We've replaced e at 1 to be 14, and then all of the other values are the same. Keep in mind that you need to import java.util.arrays. I want to show you here where we tried to um, print ln a here, and it gave us this weird memory address. I am going to show you how I do arrays. This is the one that I want. Arrays that to string a. And I will show you, it should show up on a different line, the line below. Okay, so I got this different line below. It's exactly the same. It just includes brackets and commas. So I could get rid of all of this up here, and it would give me what I need to know in a faster, more convenient way, which is pretty helpful. A couple more functions and then we will be done. Okay, so another thing that you can do is sort the array. It's going to take the elements inside the array and put them in a sorted order, with the smallest elements at the beginning of the array and the largest elements at the end of the array. Let's show you what that would look like too. So I am going to say a dot sort here. Why are you unhappy? Oh, obviously I can't do a dot sort because a doesn't have that function. I need to do arrays dot sort a. And let's see what happens. Is arrays dot sort going to return a new array to me? No, it shows that it's void. It is going to take the array itself and sort the values of it. So I'm going to print it out again after this, and all of the elements should be in a different order. So this was the original order, and then I sorted them, and this is the order now after the sorting has taken place. So that can be really convenient. So that's sorting. The last one we're going to talk about here is binary search. And binary search is really convenient. It's pretty fast, but it requires that the data be sorted at the time it is called. So you have to have sorted data, and then you say, hey, can you find a 14 for me? Tell me what index the 14 is. And it can give you that value, but your data has to be sorted first. Thankfully, we have just sorted this data. So I can say arrays dot binary search. I need to provide it the array. So that's going to be A. And I was saying I wanted to find the value of 14. So it is going to give me the index of the value 14 in my sorted array. And that is, it says that it's at index 5, 0, 1, 2, 3, 4, 5. Indeed, it is correct. This would not work if it would not give guaranteed behavior if the array was not sorted first. Okay, so I want you to take a minute, go back to the weather question from the beginning, and I want you to calculate what are the 2 coldest days and what are the 2 hottest days. Think about how you can keep track of those. Hint, hint, we did just talk about sorting, and that's pretty convenient. Are you waiting for me to give you the answer? I hope you really did pause. Okay. Anyway, I will let you do that in your own time. Please do complete that. And this will end our videos on arrays. I hope you all have a great day. Bye, team.